Have a look at it. Okay. So let me just draw the picture here. You've got your table. You've got your car here. And one here. This is the wheel. And this is 1 kg, I think, yeah. And this is 2 kg. Right, now, in green, I'll draw the forces, okay? So I think we're all happy to say that there's a weight here. And the weight is equal to mg. And what's the m here? It's 1. So it's 1g. Okay? And here, there's a weight. And what's the weight equal to? 2g. 2g. Okay? And here, there's a reaction force from the table. True? Okay. And I don't think there's any friction. I said it's smooth. There's no friction. But what to do about the string? You see, there's a string, it's pulling here, isn't it? And the string is also pulling here. Like, imagine you are the 1 kilogram car. You will feel somebody pulling at your face. So there's a force here, right? Now imagine you're the 2 kilogram box. You will feel a string pulling at your head. Yeah? So we'll call that force T. And we'll call this force T. Now you might be wondering, oh, why is it the same letter? Like, are they not different forces? And this is the interesting thing about strings, is that if you have a string which is pulled, the forces at the ends must be the same. Now, the reason why that's a little bit complicated, but the idea is if they weren't the same, then what would happen is the string would be changing its length. Because if one was bigger than the other, then the string would be stretching out. So, basically, the reason that these are the same is because we don't imagine the string as being stretched. So, like, if I now imagine you're the string. So, if you imagine you're the string, okay, you'll feel a force here and a force here, right? Because you'll feel like you want to be pulling the car, so it'll feel like the car is pulling back by Newton's third law. So these must cancel so that the total force on the string is 0. Because if they were bigger, then the string would be pulling out, and if they were smaller, you'd be pushing the string. Okay. So before I continue, is the picture okay so far? Yeah. Now, there's one thing I also want to draw on the picture: the acceleration. So what I'll do is I'll say this guy is accelerating to the right with A, and this guy is falling, it's accelerating down with A. Now, how do I know that these are the same? What's my reason for thinking that they're both the same acceleration?
Same force?
Same force, yeah. And another reason too. The other reason is because if you think about it, because the string is not changing its length, whatever this guy does, he makes this one do the same thing. Okay. So, look at this one. We can say R equals G, but that's not really helpful. This is moving to the right. How much force is making it move to the right? T. Okay. What's its mass? 1. And its acceleration is A. Okay, that could just be written as T minus A equals 0. Now look at this one. Which way is it moving? Down. So what's the total force down? Total.
30.
Which one? 2G? Is it? Is it? Neither of these. Now just imagine you are the block. There's nothing else in the world, you're the block. What's your total downward force?
2G minus.
That's it. 2G. Now why did you say minus T? Yeah. Well, why did you minus it? Yeah.
not zero?
Yeah, it's not zero, and
It's
why?
only two. It's only the block itself, so there would not be.
Because it's going downwards, so the 2G must be
Yeah,
bigger
the
than...
Yeah, the 2G must be bigger than T, and the T takes away from it, yeah. It's going downwards, and what's the M? 2, and the A is A. So you could rewrite this as, how will I rewrite it? I'll rewrite it as T plus 2A equals 2G. I just take the T to the right. Now remember, do we know G? We do. What's the value of G?
Minus 9.8.
Yeah, or rather just 9.81. So in my 2 equation, how many letters are unknown?
2.
2, yeah, what 2?
T and A.
So can you see how this is like a simultaneous equation in maths? You have T minus A equals 0, and T plus 2A equals 19.62, I think, 2G. So what would be the best way to combine them? I could subtract them. T minus T, it's gone. Minus A minus 2A is minus 3A. 0 minus, so that's minus 19.62. So then the acceleration will be 19.62 divided by 3. So the acceleration, what was that? 5.4 meters per second squared. So it's not falling with 9.81, it's falling with 6.54. And you could sub the A back into this guy to get the T, and it'll actually work out T is equal to A, so you can see that the T will be 6.54 newtons then. So what do we think of this one? Okay. What are you doing in your maths class? What topic? Have you done? You're doing cubic. So you finished quadratics, finished simultaneous. Okay. When you're ready, you can tell me what to look at next. I see on my notes I have it marked here to redo the video for this question. So there must have been something wrong in my video for this. Did anyone watch it?
Which one? This one?
Yeah. Did you watch it?
I?
Yeah.
Yeah.
And what was there a mistake in my video?
No, just the video was the wrong one,
Yeah.
I guess.
Ah. What was it a video of?
I don't know.
Not this. Okay. All right. So I'll have to fix that then. Can I just put this pen there? I'll just circle this just to remind myself. Okie dokie. Right. What are we having a look at next?
Like, I don't know why the 200 meter per second represents time.
Oh, I don't think that's 200 meters per second. I think that's 200 milliseconds.
Yeah, I don't know why it represents time.
Ah, okay. Yeah, great. Okay, let's have a look at 4. So, okay. Oh, sorry. Do you have this? Yeah? Okay. An 80 kilogram space probe, that's a space probe, in case you couldn't tell, is travelling at 2 kilometers per second. It engages a 1 kilonewton propulsion system for 200 milliseconds. So, it's 80 kg, and then what happens is it turns on its rocket. That's a flame. So that causes it to accelerate forwards. But this is only turned on for 200 milliseconds. So what happens is, first it's going at, what did I say, 2 kilometers per second? Then it turns its rocket on, and then it speeds up, and now it'll be going faster than 2 kilometers per second, because it had its rocket on for 200 milliseconds. And what's my question? How fast is it going? Okay. Oh, and I know that this is 1 kilonewton of force that comes out the back. Right, so I want the V at the end. That's what I'm looking for. So Newton says F equals ma. Okay, do we know the F? We do. Do we know the M? We do. Do you know the A? We don't. Alright, well, we know that A is V minus U over T. So if I cancel, I'll have 100 over 8, which is 12.5. That's equal to A, which is V, which we don't know, minus U, which we do know, over T, which we do know. So it will be 12.5 times 0.2 plus 2000 will end up being B. So V, if I got that right, V will be a fifth, so 1.25, 2.200, 2.5? 20, what? 2003, if you round it up. Oh yeah, so I wrote 2003, did I? Did I? Yeah, so it must have been 2002.5 or something like that. So 2003 meters per second. Okay. Happy with this? Yeah? Yeah. What's next now? Huh?
In the weights and drag, you said there's a 5% chance that those questions will come?
Yes.
I didn't get any of them right.
I see. So we can do some of these for sure. Which ones do you want me to do? Or will I just start with the first one? Yeah, okay. Right, so on the next page now. How did the weight and drag lesson go for the rest of you? Kim, how did it go? Were you more successful? Did you get any of them?
I got 1.
Okay, well that's one more than your neighbour. And up the front here, how did this one go?
I got 3 and 1 with the video.
Ah, you got one by yourself,
I got 3 by myself and
one with the video. Oh, good, okay. And you? 1? Okay, the first one, yeah? Okay. Do you know, would you mind if I did the second question? Only because since a couple of people actually have done one, but it seems like some people have trouble with 2. It might be good to start with that. And I also noticed that my video needs to be redone for number 2 as well. So I think it would be good to do number 2 for this one now. Okay, so number 2 is quite tricky. It's quite long as well. What was I thinking? Okay, right. See, what happens is I imagine these physics questions. You know, I'm sitting on the train and I'm thinking, this would be an interesting question to do. So here, this is somebody fires a bullet straight up in the air at 256 meters per second. And it's a 42 gram bullet. And it'll take 18 seconds to reach its maximum height. That'll take 18 seconds. And my first question is, if you ignore the drag force, how long should it have taken? Okay, so the 18 seconds is because there's a drag force. But if there was no drag force, I think it will take longer than 18 seconds to reach the maximum height. Because what happens is when there's a drag, it slows it down quicker, which means it'll reach the top sooner because it'll reach 0 speed sooner. Okay, so if there was no drag, what should it have taken? Let's calculate. U, okay, so this is A now. U is 256, V is 0, A is minus 9.81, T we don't know, S we don't know. T is what we want. What gives us the T here? V equals U plus AT, huh? V equals U plus A T. So, of course, what did I write 9.81 for? That was ridiculous. So 0 equals U plus A T. So T is 256 over 9.81. What's that, about 25 seconds, something like this? 26.09 seconds.
Yeah, but 26.0958, so it's 26.1.
Oh, 26.1 then, let's say. Okay. How long did it really take though? It took 18 seconds. It should have taken 26 seconds. Okay. B. If you include the drag force, what was the deceleration? In part A, what's the deceleration? Yeah, but because I said deceleration, you don't need to say negative again, so it's 9.81. Would the deceleration, now think carefully, would the deceleration in B be bigger or smaller than 9.81? That is, if you do include a drag force, it'd be bigger, yeah. Yeah, because it'd be slowing down faster. Okay, so my question is to calculate that. So the U is 256. The V is 0, the A we don't know, the T we do know, the S we don't know. Okay, let's calculate now. Same deal? No, not same deal. I'm looking for the A. Oh, no, it is same deal. V equals U plus AT. So the A will be minus 256 over 18. Yeah. Which is more than 9.81, isn't it? What's that now?
14.22.
Oh, 14.22 meters per second squared. Okay. C. What is the net force acting on the bullet on the way up? So when you look at the bullet as it's moving up, what forces are acting on it? What forces are on it? Don't be shy. No, actually. Huh? Say again? No trust. That's what he thought as well. There is no trust. There is no force pulling the bullet up. It's not like a rocket, you know. It's more like something you just throw. There's no force continuing to make it rise. So there's gravity for sure. So that would be mg, which is 0.042 times 9.81. Okay, because the weight, the mass is 42 grams. Yeah. And what else is on it? There's a drag force, isn't there? Yeah, which I'll call D. Yeah. Now you actually, you have a way of working out the total force from Newton, because Newton says the total force is ma. Do we know the m? We do. It's 0.042. And do we know the A? Yeah, it's 9.81. Now this force is acting down. So actually, I don't even need to consider the two forces because I already know the M and the A. I can work out the total force by just multiplying these. So what would that be? That would be 0.
Should not be negative.
Yeah, that's why I wrote the word down here. Just
Oh,
to
if
remind
you
me.
just write down, you don't.
Yeah, that's okay. Yeah.
But you
yeah.
can add the negative and not add down.
Yep. Yep. What's that, Matt?
0.412.
412 newtons down. So I'll put the minus in. Okay. D.
It's different from that.
Is it? That's outrageous. 0.5973. Well, maybe I misread my question. Yeah, my answer's wrong there. Can I have a pen there? No, you're right in there. Thank you. I don't feel like I made a mistake there. What did I say? 0. Okay, so that should be now.
If you multiply by the B answer, you get your answer.
Sorry, my mistake. Bad teacher. Sorry. I put in 9.81. I shouldn't have put in 9.81. I forgot what the A was. I just worked it out right there. It's minus 14.22. Goodness sake. It's terrible. Alright. Is that the right answer?
Yes.
0.5973 newtons. Okay. D. What is the value of the drag force? What's the value of the drag force? Okay, we can work that out because if we look here, we know that the total force is equal to two forces. The total is equal to the drag plus the weight. Okay, because these two together is what makes the total force. So 0.5973 minus 0.042 times 9.81, that's equal to the D. The drag force is 0.185 newtons, I hope. We can double check that when you're ready.
You need to add negative.
I should at least write. I kind of drew the drag in the diagram, so. You know what I'll do, Matt? I'll just write downward beside it. Okay. Can I continue? Yeah. Now, before continuing, I know from last year the next part of the question will be a little bit easier to do if I go back to part B and work out this S, which I haven't worked out yet, which is the distance to the maximum height, you know, when the V is 0. So if I just temporarily go back to B, let's work out the S. The S is U T plus a half A T squared. So if I can borrow this, please, I'll just put that in. 256 times 18. So I get here 2304 meters as the S there. I'll need that for the next part. Okay. Can I scroll down? Yeah? Okay, so let's look at the next part. So, the next part. When the bullet reaches the maximum height, it begins to fall and reaches a terminal velocity of 25.6. How long until it reaches this velocity? So, this is what's happening, okay? Here's the bullet. It's at 256 at the beginning. It goes up, and then at this point, what's its speed? 0. Yeah? Then it comes back down. But at some point, let's just say here, it reaches a maximum speed of 25.6.
Maximum?
Yeah, and then it will continue at 25.6 until it hits the ground. Why does it reach a maximum speed? What's this called? Do you remember the name for this?
What is what?
When the maximum speed. It had a name last time. Remember the man with the parachute?
Oh.
Yeah. Anyone remember? Terminal velocity. And why do we have terminal velocity? Yeah.
Because it reaches a point where the upward force
Mhm.
and the downward force cancel.
That's it. And in this example here, what's the downward force? Yeah, it's the weight. The weight. And what's the upward force? If it's when it's moving down. Yeah, go on, don't be shy. The drag, yeah. You don't sound sure, but it has to be. 'Cause, you know, it's falling through the air, so the drag is upwards, yeah? So my question is, how long does it take to reach its terminal velocity? Okay? So let's write down the info. U, V, A, T, S. We know the U. What is it? 0, if it's from here. Okay? We know the V is minus 25.6. Okay? Do we know the A? Well, we'll have to think about it. We don't really know the A, or the T, or the S. Alright, so we have a little bit of a problem, because we don't really know the A. Why don't we know the A? Well, there's a lot happening in this story. So, for example, at the beginning, when this was moving up, it had a downward acceleration of 14, I think 14.4 or something, wasn't it? Well, something like that. Now, will the acceleration downward for this part of the journey be bigger or smaller than the acceleration for the up part? So if you were to compare the two, would the acceleration for this part be the same as for this part? What do we think? No, it wouldn't be the same. It'd be smaller. Now, why would it be smaller? Words are difficult, I understand. Let me explain. So, look, when this is going up, how many forces are acting down? 2. So they are working together to slow this down. Okay? But when this is falling, there's one force down and one force up. So are they working together now? No. This guy is opposing this one. So that will make the total force down bigger or smaller? No, smaller. Because if this is going down with this force and he's pulling back, the total down will be less. So if the force is less, the acceleration is less, because Newton said F equals ma. So because Newton said F equals ma, then A is equal to F over m. Now, do we know the m? We do. Now, what is the F going down here? Total downwards. It's the weight minus the drag, which is something we just worked out. 0.185. So the acceleration is about half of what it was previously. It's minus 9.41 meters per second squared. But that, I mean, I'm not finished yet because I didn't want the A, I wanted the T. Can I get the T now? I can. V equals U plus A T. So T is 25.6 over 5.41. What's that, please? About 5 seconds, isn't it? 4.74 seconds. Okay, and finally, at last, F. What is the total time for the whole journey? So we need to break this up into 3 stages. So what's the time from here to here? From here to here, we know this one. It's given to us actually. 18 seconds, isn't it? Now what's the time from here to here? We worked that out. That's 4.74 seconds. Okay, what's the time from here to here? The last stage, here to here. We don't know. We have to work it out. Okay, so if I think about the triangle, distance, speed, time, how do I get the time? Distance over speed. Now, do we know the speed for this last part of the journey? Yeah, what is it? 25.6. Do we know the distance for this? No. But, do we know the distance here? Yeah. And could we work out the distance here? We could, because that's just this S. So, S is UT plus a half A T squared. What was my T? 4.74. Okay, so what is that, please? Sorry. 5.41 divided by 2 multiplied by 4.74 squared, if you don't mind typing that in, please. 5.41 divided by 2 times 4.74 squared.
60.775.
60.
Yeah, 60.775.
So 78, we'll say, meters. Yeah. And what did we say the maximum height was? Like 2,000, what was it? 2,000, was it? We worked it out earlier, didn't we? Where's it gone? Where is it? I worked it out. 2,304 meters. So that's 2,304 meters. That's 60.78. So what's this last distance here? Well, it's the minus them, isn't it? So we'll just put into this 2,301 minus 60.78 divided by 25.6. So that's the total time. And I'll type that in while you're writing that down. Okay. That's quite amazing. My answer's right. I wrote beside it to check the answer, but no. I got the same answer as I did last year. 110 seconds. Tricky, huh? That would be like that question in the exam would be like 15 marks. Like out of 100 marks, 15%. It'd be a section B question. It'd be a long question. Okie dokie, you have this written down? What's next now? How many people managed to get the projectiles finished? No. Because you didn't have enough time, or they were too hard? Yeah. So would it be better to look at projectiles next week when people have had time to try them? Yeah? Because it sounds like people are up to the weight page. Yeah. So will we look at projectiles next Friday? And we'll just go on to the next lesson. What's my next lesson? Yeah. Okay, let me just save this and we'll continue.